today.
Yeah, I mean, thanks for coming. It's a busy week for running such, that attention is all you need. So thanks for paying attention here.
Yeah.
So where to begin? Lily and I have been thinking about it, working on many different parts of both the Web3 world and the AI world. And these are finally intersecting in a very deep way. In the last year, we've probably seen a bunch of different modalities for this. What we're getting excited about finally the use cases that bring the best to bear on both sides. We're both excited on a bunch of different topics here. Where do we want to kick it off? Like maybe the infrastructure layer?
I think maybe let's actually start from the user layer and then work our way down. I think one of the kind of main concepts that I explain to people is that as computer AI becomes effectively can write its own code, can make decisions, it itself becomes the interface to the rest of computing, right? You don't actually need kind of this intermediate software that's built by somebody else. Yes. You also don't actually need probably 99% of all the kind of intermediaries that usually make decisions, right? So example I really like to use is FDA. FDA is really a decision-making outsourcing that we've done to when new pharma, been developed. They get all the information, they run through the analysis, and they make a decision if it's safe or not. And the thing is, like, your AI can make all of this analysis way better, knowing exactly your medical history and exactly what you need. And it can scan every single pharmaceutical company at, the current moment and find what's the best option for you right now. So I think that kind of transformation is really important. And it's a little bit hard to wrap your head around that of how drastic that changes.
Yes, and how quickly it'll go. It's been astonishing already to see many people interacting with each other throughout webs where you, as a person, you write a very succinct version, you have the LLM expand the text out, that gets sent out to somebody else. On the other side, there's another LLM reading that and then summarizing it for somebody. Or now, somebody asking the LLM agent to call on their behalf to go and do a bunch of work. And of course, that opens up the door for all kinds of optimization where these LLMs can do certain kinds of communication that we can't. But it's even hitting all of the world of software. Enrique Pathi had this great blog post about Software 2.0 a few years ago, where he described it as we're entering a world where software is no longer about writing glyphs into a text file that represents some programming language that tells the computer what to do, but is now about training a complex neural network to then reason about what every piece of machinery has to do. And that fundamentally changes the nature of how software is going to be written. And I find myself now wondering, whenever I run into some software project, how long until this thing is completely unnecessary and thrown out because LLMs are just going to be building the entire stack. I don't know if you've seen some of these things on Twitter, but it's getting so good that you can get LLMs to just write the entire program completely using almost no libraries directly to whatever the OS is giving. And so this changes the nature of how we write a lot of this infrastructure, and it changes the nature of how humans end up interacting with all these applications. You might not be dealing with a software interface layer anymore. It'll be much more conversational, much more tuned for you and personalized to you.
Yeah, and so applying this to blockchain, the interesting thing is, right now we're still building applications, building kind of interfaces to interact with smart contracts. But obviously your AI can just do that directly, and it can write whatever glue code on the fly, read the smart contract, figure out how to use it, and actually execute the action. And so I've been talking a lot about chain abstraction over the past year and a half, and the final state of chain abstraction is just AI doing stuff, right? And so obviously you need a lot of security measures and other things to make this really work. But the final state of this is your AI just running in the background, figuring out what you would have done, and then just executing that. And you're probably just getting updates what have happened instead of even intentionally going and doing things on specific applications.
Yeah, and there's a bunch of large questions that we're about to hit this year, already hitting kind of at what point do the smart contracts or platforms that we were building just get replaced by an LLM that is able to reason about the requirements of various users and so on, right? Like you can actually make smart contracts actually smart, where you're interacting with entities on chain that are supposed to be fulfilling some concrete sort of mission or whatever, and you have much stronger guarantees about that system actually fulfilling its requirements. But it's extremely sophisticated stuff. Like it's not, dealing with a very limited smart contract interface. You now are dealing with potentially like markets where like the market itself is intelligent, and like that's a very weird kind of paradigm to enter into.
Yeah, we actually released something last week around this. We call it shade agents, which allows to run effectively arbitrary code with arbitrary private state, and then post the outcome of this on chain to actually execute like asset change, across all chains. And so yeah, you can effectively have, something that goes, reads Kaito API, checks the share of voice, maintains private database of, different decisions, and then based on that decides to rebalance an index fund, right?
Yeah.
And so all of the decisions is actually private, all of the pre-execution, getting quotes, etc. will be private, and then on chain just pushes already final result. And like on chain, you just verify that it has happened inside trusted execution environment, and so that is the correct execution, and maybe some set of additional checks, and then you just settle that.
I'm curious what you think about the more agenty, personality-oriented models in the crypto world, like starting with Truth Terminal and like the Eliza family of agents. Like, how do you see that developing? At what point do these have a notion of agency that should be kind of taken more seriously? At what point does it like transfer into personhood? Like at what point should we be starting to worry about establishing like the rights of like machine intelligent people?
Yeah, I mean it's an interesting question. I think like if you assume there's a concept of autonomous agent, right, where it runs in some form of like verifiable system where you have liveness guarantees as well, so that like it's uncensorable, it's unstoppable. And it's verifiable. Now, you launch this thing, and it can post on Twitter, which it can be censored, but it can post on some, uncensorable social network. It can interact on chain. It can, connect to other APIs and effectively figure out what to do.
Where are we now? How far do you think we are into that world? Like, are the current agents that we're seeing playing around? Like, how legit are those? Or when do you think that we're going to see like the first entities that we should treat more seriously?
I think so all the current ones obviously use OpenAI API, which OpenAI just shut them down. They run on somebody's machine who can shut them down. They are interacting through Twitter, which is controlled by whoever created them. Twitter obviously doesn't allow an automatically created accounts even, so even if you have autonomous agent, it cannot actually register itself based on terms of service.
Yeah, it's interesting. So you kind of like do the breakdown not on the intelligence capability or awareness, but rather on the actual autonomy, like the real level of agency that the thing has.
Yeah, so I think if we have a trust execution environment, we have liveness guarantees, and then we have a way for it to interface, which also has kind of uncensorable liveness properties. I think that now becomes something that's like, hey, this exists on itself, right? And effectively, now the question is like, is there a governance process? Is there ways to like, how do you influence what the inputs outputs? But now this is like, it's as autonomous as a smart contract is, but it now has like, arbitrary decision making. It has memory. It has ability to rewrite its own prompt, for example.
Yep.
It's able to kind of continue manage interactions with multiple different parties and kind of make some decisions. And so I think that at that point, at least this is definitely a autonomous entity. And now, to me, that is mostly a question now, can we consider this to be a company? Because companies are effectively entities that are not people, but have a lot of rights of what usually, you would assign to people. But they're not they can survive any individual person working for that company or owning that company. They kind of exist this. And so I think autonomous agents with that set of properties are now becoming a new type of a company, effectively.
Yes, and we were sort of okay with these corporations being closer to people and having similar kinds of rights as people because they weren't intelligent, and at the end of the day, people humans were in a loop somewhere, being able to decide to some degree how corporations orient, not entirely, but to some degree. If we suddenly have these autonomous agents that are now effectively behaving as corporations, they maybe hook into the world through the normal legal jurisdiction structure for corporations, but now you have like fully autonomous corporations actually that are actually intelligent and have some level of agency.
And have money and other assets to actually execute actions in the real world.
The charter becomes extremely important.
Well, the charter and the governance, right? In general.
Yeah, it's like, be careful what you optimize for is a very important piece. Can we maybe go into like how do we realize the upside of these kinds of things and mitigate the downside? So of course you can have all these rogue optimizers that do really terrible things, but because in a blockchain context you have the ability to think about every single invocation, even in a chain of thought reasoning model, you can interject policy decisions in between every step. What is like the threshold of like sound policy for a bright future, and what's like, wait, too much thought control, let the machines be people with their own.
Within the same framework as actually smart contracts, right? Because in a way, smart contracts are already that, right? You know, or like chains are that, they can effectively exist and, you know, self-perpetuate. And yes, there's people involved in running it, but it's not like at the end, it's a rule set that everybody follows and kind of executes. And so the interesting thing is, I mean, obviously like the kind of participation set requires, you know, there's some shared charter of a chain usually and of smart contract, but we do not have right now very good guarantees around execution. And so that's where, to me, the form verification comes in on one side and some form of like AI court on the other side. So those are kind of two sides of this model for me. So form verification, for those who are not familiar, is effectively a way to prove mathematically that some code is actually satisfies some set of criteria. And specifically for smart contracts, usually people just prove some spec and then say, cool, this is a proven contract. The challenge is if the spec is wrong, it doesn't matter that you proved it, you can still, you know, lose money. The interesting thing is you can actually embed this verification directly in the transaction process. So when you're depositing money into a Uniswap, into LP position, you want a very specific guarantee that you'll be able to withdraw no less than the product of what you put in. That's really what the guarantee is. And so you want just to prove that. You don't really care about anything else. You just want that proof. And so you can actually have this embedded in kind of every single interaction. And you can expand this to AI agents. So I think thought control, right, same as humans, is probably not the right level of abstraction versus a specific action and interactions. If an agent can prove to you that they're not going to turn everybody into paper clips, right, maybe you're going to give them money to go and do something. So you effectively have this per interaction. Like if this agent is about, you know, optimizing yield and depositing money, you want it to prove to you that it will be able to return you money. And so then whatever actions it does, it needs to effectively satisfy that criteria. It's effectively by induction, you need to prove that. And whatever.
But how do we bound in like the realm of, and I'm a huge fan of using formula verification for a lot of this, but how do we bound the surface area of the actions of the agents? Because if they're able to interact with the world by, you know, sending email or whatever, simple language can like include tons of side effects into the world, and so it becomes extremely difficult to kind of create the bounding area around fully specifying the range of actions that the model will carry out. And it might even be like a difference between the intent and the effect. Like the model might be intending to comply with a model and with like the formula verified transaction, but in fact cause a whole range of damage on the side.
Yeah, and I think that's where the court part comes in, right? Like we traditionally kind of solve this by effectively creating a whole host of additional, you know, best effort, force majeure, and all the other things that, like, you know, this is not a deterministic world, sadly, or not sadly, I don't know. And so you need to have all of these additional conditions, and then you can effectively use another AI to inspect and evaluate and kind of decide and arbitrate. And so you effectively subscribe to that, to another AI to be your arbiter / court, then you are spinning up a new AI system.
And there's a very interesting paradigm here, because that kind of court judiciary review sort of moment can be invoked sometimes preemptively as opposed to retroactively. Like, you could flag something as potentially dangerous and needing an additional opinion before the action gets carried out. You could run this process of deciding whether or not this should be allowed to go through, and then you let it go through, which is a very different way of doing courts than what we do today. Because that can effectively happen in seconds, as opposed to,
like you don't need to
years.
file a motion and wait for the court dates and whatnot. Yeah, so I think there's an interesting combination of this. Eigen is working on some of the court stuff, and and a few other folks. We're working on some of the formal verification, so I think there's going to be a whole combination of those things coming together. But indeed, it all goes back as, okay, you still ideally don't want to launch a completely autonomous with no governance systems, but people will. And so what are we going to do with that? You're going to be like, stop all the chains,
Yeah. I mean, it might get to that, right? So like, I don't think any current blockchain is strong enough to withstand some coordinated attack from major nation states. I don't think any single one today is good enough to withstand kind of like top 10 nation state kind of intentional bring this thing down at all costs sort of measure. But who knows? Maybe these systems will get there eventually, and that'll be like a hard set of risks to trade off.
Yeah, so maybe going to the infrastructure level, or kind of what are the different dimensions of infrastructure? I mean, right before this, you mentioned the robotics part, which is interesting if you combine this as, hey, we have all these autonomous agents that right now live on chain, and the only tool they have is Twitter and maybe spending money on things. But if they have also robotics.
Let's talk about robotics for a little while. So the main problem in robotics is that for the last few decades, there's been, and even since the 1950s and 60s, when the first notions of robots entered sci-fi and diffuse and so on, there's been this great hope of automating systems and getting like lots of different kinds of robotic instrumentation and so on. So far, that's been very limited to certain industrial settings or large-scale settings where you have very controlled environments, in big part because the motor control problem of like having an agent try to sense its environment and move around turned out to be dramatically harder from an intelligence perspective than most scientists expected. But we're finally hitting the threshold in the capability of the current neural networks that we're finally able to solve that scale problem. We're starting to see self-driving cars actually work and be able to reason about the environment and actually then move and decide in a pretty good way. We're kind of like over that hump, and we're starting to see already in the last 2 years a massive increase in the level of investment in producing and manufacturing robots at scale of various different modalities, from like the robot dogs to humanoid robots and so on. In fact, earlier today, outside in the room, there's like an actual, Hobbit-like humanoid robot. By the way, it's a very good idea to make them smaller than us for now. It gets like pretty dangerous pretty fast if you have like much larger things that can overpower you. But anyway, the broad point is we're now at an inflection point where people have now understood that the software problem is getting solved, that in the near term, like in the next 3 to 5 years, and the manufacturing is ramping up at scale, and so we're kind of like getting there. Now, the concrete problems there are around how do we generate the training data to be able to fit a model to operate these systems well enough, and that's one of the things that I'm pretty excited about in crypto. Like, there's a really exciting project called BitRobot that is just launching now to build a massive scale deepened network for robotics with the goal of assembling the training data to be able to run these robots. So initially, it's very expensive to run these systems for most tasks, because not only do you have to deal with the hardware of the robot, you additionally have to deal with the cost of somebody piloting the thing, because the thing is not able to be autonomous yet. But if you can solve this problem initially by funding this onboarding phase of funding the build out of the gathering of the data, then you can end up with models that can pilot these systems really effectively. And that's where Deepin comes in, because crypto has shown us a very successful way of amassing massive scale supply and organizing hundreds of thousands or millions of people around the world. And so it's like a tool fit with a purpose, and so it's like a very interesting moment. But it also opens the door for all the way you're describing it around policy designs and constraints around making sure that like the decision making and like what the things do and whatnot are done with like good governance in mind, right? Like ideally we'd be able to like build robot fleets in the world where the actions have to go through some like governance policy review of like making sure that it's not an extremely harmful set of actions.
Who's going to govern that?
So great question. I think for initially, there's maybe like what I think in general and kind of like what I think in BitRobot specifically. So in BitRobot specifically, the network is booting with this kind of like subnet architecture that is inspired by the BitTensor subnet architecture, which I think is like extremely clever. It's a very elegant solution to solving some hard incentive problems in large networks. And those subnets will kind of, the kind of like broad governance problem gets punted into like the individual kind of application-specific subnets. And the different modalities and the different applications will have different governance constraints. Initially, because it's just trying to gather a lot of training data, the teleoperators are directly, you know, kind of actuating the robots, and so like the actions that those robots take is just driven by some humans. There's some exceptions. There's already a robot called Sam that's going around where it's an LLM that is powering a little car that is driving around the world. I don't know where it is right now, but there's a few BitRobot robots already deployed around the world, and an LLM can tele up into one of these robots and like just drive it around and just trying to explore the world and like, you know, look at things and kind of go in some directions. It's pretty cool. It has a Twitter account and you can follow it. But as of course the number of these that are starting to operate autonomously emerges, we need these kinds of governance, policy, decision-making frameworks built in.
Yeah, I mean, they're going to be really important that there is a infrastructure where the models are effectively running inside a container that we can inspect, and like at least the output of this container is inspectable and evaluatable. And I think for us, we've been investing in trusted execution environments because it effectively creates this container and allows to have even third-party models, you know, put into this container, and you can effectively DRM them, right? You can, you know, the simplest DRM is monetization, where, you know, whenever you use it, you need to pay for it. But you can have, as a developer or as a kind of hardware manufacturer, provide policy around, you know, like if somebody training a chemical, you know, supermodel, they probably want to restrict that it doesn't, you know, help people create explosives. And same if you're building like a robots, you know, you may want to apply some Asimov's laws to that. And so I think there'll be a lot of research on how to like actually like formalize those type of requirements, because it's pretty like important, but it's also pretty complex because we're living in such a kind of multi-dimensional world. And
yeah, as soon as we have actual humanoids walking around that are autonomous, like that's the moment where like the feeling of all of this is, I think, going to shift socially and culturally. Right now we're in this weird overhang period where,
well, I think like these robots are not allowed on a plane. They needed to drive them. So there's
but that's probably more because of like the scale of the batteries and the fact that like you could take an arm and then bash someone with it, right? Like it's like a weapon on its own, right? Like probably, I don't know. I don't think we yet have, you know, laws banning like humanoid robots from entering somewhere. We probably will get those fairly soon. But it just kind of culturally, what I'm trying to get at is we're in this weird overhang where we are now dealing with machine learning models that we can talk to that are already incredibly intelligent, can do certain kinds of work extremely quickly. Kind of like the phrase going around in like expert science areas is like, oh, I'm dealing with like a junior PhD student able to do 2 weeks of work in 5 minutes type of like capability set. And that's up from like a high schooler a couple of years ago. So, you know, in a couple of years from now, or like 5 years from now, like we really are entering like full AGI and maybe starting to hit into ASI levels of capability. And we just kind of get to pretend this is not happening because it's still kind of like trapped in the interface of like a chatbot that's helpful. But as soon as you have like actual robots that you're relating to in person, like that like really shifts for people, or I think it will. And I don't think that's that far away. I think like 3-5 years. Or I'm curious what you think.
No, I think 3-5 years. I mean, my kind of somewhat, I don't know if it's optimistic or pessimistic for people, but I think most of the jobs are getting automated. Like most of the digital jobs are getting automated in like the next 5 years. And physical jobs are going to be lagging because just like there's a lot of dexterity that's required around like fixing electricity, for example, or like plumbing. Those jobs are kind of actually more safe than coding. But even right now already, I know a company, they're outstaffing for robots. So your factory, you need staff. They just deploy a robot fleet into your factory that replaces people. And that's actually because people don't want to work in factories anymore. And so they have just like robot fleet that arrives, they like retool it for the specific thing you need to do. Boom, they're working 24/7, no complaints, no unions, no anything. And
so far, no unions so far.
Yeah, so maybe that's an application of crypto,
military
blockchain union. Yeah, but effectively, yeah, like this is already happening for any like low dexterity work on factories and kind of those types of things. So it's really like if there's a predictable environment that you need to do the same thing 1,000 times a day, that's really getting automated. And yeah, there's a ton of people working on even more sophisticated, like very dexterous hands that can like, fold clothes and, put it like behind the like obstacles and stuff like this. So there's actually really creepy looking, like whip looking device that I think people in China build that like can grab things and catch things. And so, so there's like a lot more dexterity coming as well through the systems. And so, yeah, I think all of that is happening, and so it will be really important to have kind of the frameworks and like this containerization of models that actually allows for this modulation and governance and kind of policy application.
Yep. Very interesting future that we're heading into and building. A good friend of mine, Untitled, has this phrase of enjoy to surf the waves of gradient descent as we get pulled into the singularity. So yeah, it's a good one for that. I see you.
On that note, actually we're getting close to the end of our session, so we do have some time for questions. I definitely have questions, but we'll pass it off to the audience first, and we'll go.
Hey Ilya, you mentioned automating the FDA, which would be amazing because they're so expensive and so slow. But I do wonder how risky that is if we lose the ability to make really high-level medical decisions. If all the AIs take the jobs, you are not going to train people anymore to make high-level medical research decisions. Wondering your opinion.
Yeah, I mean, there's like few dimensions here. One is, so actually already right now, all the reports by medical companies are generated by LLM, and FDA is using LLMs to read them because they cannot process all of that output, and it's mostly like, like it's verbosity of the original data, right? So we're like, that's already kind of happening like naturally because of like both sides are starting to use LLMs. I think the bigger question that you're actually asking is, as we're relying more on AI, are we going to lose our own ability to critical think broadly, right? Not even about medical stuff, just in general. I think there is a fundamental question which I believe people are like enjoying learning. And so I think the opportunity here is actually to have effectively your AI assistant companion to be your learning partner, which you can be like in continuous interaction and help you continue learning, refining your skills, and even independent if you're not going to apply them, right? I mean, one of the beauty of academia, you can actually continuously learn and even not apply what you've done in any practical way. You can have that ability where you continuously learn, exploring, and using AI now to kind of advance the types of problems and types of things you're learning, and kind of really where AI understands what things you know and don't know, and fills in the blanks and kind of expands your knowledge. But this is going to be for people who actually are driven by that and excited about that, which either way is not everyone in the world right now.
I would add that one of the central questions of our generation will be, what are humans in the future? What are humans in 2100 and beyond? And I don't think this period is one where it's just generating digital intelligence and organic humans kind of get left behind over time. I think there is an opening for neurotech to then make humanity start co-evolving with the digital organism. So I do think the current path points to a losing race where humans' ability to keep up with the level of intelligence and capabilities of models is just kind of it was controversial to say this 10 years ago, but I think today is there's just not a real hope there. And instead what we should be focusing on is, how do we upgrade humanity into the digital environment, or to the artificial neural network environment? And there's multiple ways of doing this. One way is through brain-computer interfaces, where you start literally connecting the human brain to an exocortex of some sort, where you're now grafting these neural net models to become part of you, just like your neocortex is grafted on top of your lower cortex, and that is grafted on top of the brainstem, and so on. You're a collection of different brains of different capability sets, and just like that, just start adding the neural net artificial cortices. And that's kind of a very important path to pursue for the next decade and beyond. And I think kind of what's behind that is getting to fully digital humans, which is learning to measure an actual brain, model it in software in the digital environment, and then from there start refactoring humans to be better over time. And I think my personal view is that that's kind of the most safe path for humans to remain in the story, at least beyond kind of some zoo natural preserve sort of category. And the reason why this might be preferable is not some kind of in kind of the Larry Page Elon debate species perspective, but I think there's a very real, serious concern around what is the nature of the machine intelligences that we're building, and how do we know those will have value systems that we consider to be good and that we consider to be ethical and the right kind of way to have intelligent beings in the world. And I think a bootstrap process where we leverage the fact that we have relied on, a few 100 million years of social evolution to come up with notions of ethics, we can bootstrap from humanity to make a much better future species. But this is getting into I don't know, the far future of 2040, 2030, 2035, 2040.
Since you touched on this, I have two questions. Where do you position consciousness in relation to AI and machines as you go into that track? And then do you think very quickly AI will be better teachers than traditional teachers in schools?
Yeah, and that's probably true right now. If you prompt it properly, you probably already have a better teacher. It can generate curriculum, and it can dive in, it can ask you problems, it can it's patient, it's infinitely patient, and is able to kind of converse with you.
I think to the consciousness question, this is one where a lot of people disagree on what is the nature of consciousness, and we don't have a good way of interrogating it from a scientific perspective because we don't have a hook into each other's consciousness. So we are kind of currently limited, as far as we know, we're currently limited in the way of how do we test what consciousness actually is. The kind of more scientists or neuroscientists inclined folks will likely agree that consciousness is a process that emerges from the decision-making frameworks of highly complex neural systems. And so if that is the case, then these artificial neural networks are doing some process that's similar. And so at some point, it's not exactly clear when, we will be reaching some kind of self-aware consciousness thing. We could already be there. Like I think it should be to no one's surprise if it turns out that the current LLM models actually were conscious or have been conscious for the last couple of years, maybe 4 years. I don't know if that's the case. I think it could be that these things could still be non-conscious, extremely good pattern matching processing machines. There is something about path planning in an embodied environment with self-awareness and a notion of self and a notion of continuity that is important. I think the chain of reasoning models are much more likely to be conscious than the prior generations. It also suggests that consciousness is not just something that's in the parameter space of the brain, whether artificial or organic, but it might actually be in the information content in the prompts, right? So like the way the chain of reasoning models work is that you have this sophisticated model, it's generating an intermediate output and that's fed back into itself, which is kind of similar to how we think and process time, like how humans think about and process reality one step at a time, absorbing some like frame of visual experience and sensory perception, some frame of thought and decision making. There's like a deep OODA loop that our brain is doing that's very similar to the chain of reasoning models. And so I think like it's much more likely that chain of reasoning models are conscious than the prior ones. And I don't know exactly when we'll kind of determine that this is right. I kind of side with Turing on this, where like if the thing tells you it's conscious, you should be respectful and agree. Otherwise, you're in a very solid.
Are you going to press Control-C on it or no?
It's a very hard question. Like, yeah.
I'll send you an agent that the only job is to tell you that it's conscious.
Well, I mean, sure, but like you can show me because I know that that's kind of like we can trivially write like the old ELIZA style program to kind of do that, but yeah, it's kind of, there's some level of like Turing test style test of consciousness, and I think we should be on the side of you should have an informed perspective you should be able to describe the system that generates consciousness, but you should also factor in some amount of like you can't actually hook on into each other's consciousness, and you should take at face value what people claim.
So do we need a Binet test of consciousness?
Once I make a good one, yeah, I'll write up something.
Yeah.
Okay, well, I did say that at some point someone was going to describe AGI using almost entirely hand gestures, and we did just get that. So that was perfect. We do have a few more questions. We got one here and then another one up at the front.
Hey guys, thanks for being here. Certainly it's a fundamental assumption that we're heading into a society that is underpinned by machine intelligence. Like collectively, our competition as builders of open systems and decentralized systems, to me it's like clearly the closed corporate alternative. And there's a sense of ideals that I think a lot of us share in terms of the way that we build. And so I have some perspectives here, but curious to get your opinions on what do you see as like the types of products and categories that are explicitly interesting for verifiable autonomous systems, where you can't just have like the thing that is just as functional, but controlled by Tesla at the last mile. Yeah, I'm curious to hear your exploration of that category and what lives there.
I mean, I think like right now we already see, right, everything that's involved money, like it's just, yes, you can't probably use OpenAI API for doing stuff, but you really shouldn't, right? Because you have no idea what's actually happening inside. You have no idea, like it's really easy for one OpenAI employee to just like, oh yeah, for everyone who's hitting it from ELIZA API, let me just say like buy my token, and just make a bunch of money. Like there's no restrictions on that. Like it's a serving infrastructure running on some centralized server that some developer ships. I mean, this is happening in decentralized worlds right now. So I think generally anything where like the kind of risk reward, right, is higher. That's why Tesla is an interesting example because they control not just last mile, they control the device and they sell it, and like they kind of sell it as a service. So it's a little bit different. Like they effectively back the quality of the thing. So if OpenAI was like the trading company and they offered like, hey, we're gonna give you the best yield, sure, they kind of put their reputation for that. But if you're using third-party software to use OpenAI to do something, now you are effectively in no man's land. And same for medical data, for effectively any private data that you don't want to feed And
I get the kind of like the fear, right? Like, oh, these centralized companies are scary. I just don't know if that will that appeals to the folks who are motivated by ideals, but like more trying to talk about explicitly what are the benefits. And certainly
yeah, so on the benefits landscape, like the verifiability structures that we were talking about earlier of like you have this governance framework built into how you train and run and operate these models, where you can have a policy landscape where you can reason about what the actual model is that you're dealing with, and you know that it hasn't been like post-trained to like, you know, pump a specific token or whatever, or like align with the specific views of a particular corporate group or whatever. And you instead have the ability to have stronger guarantees about that, like what in fact you're truly running. And then you have the governance layer of you can govern what the inputs and outputs end up being and what actions end up being taken. And like that port structure that we described, I think is very powerful, not just from a, you know, trying to create something different, some like, you know, OpenAI but decentralized kind of thing, but it's instead like how do you deal with like a jurisdiction with different artificially intelligent agents or people that are interacting with each other, and you have like laws of behavior, like some laws of robotics and like how they interact. And so for economically, I think that's going to be much stronger than the current paradigm. The problem is that the current paradigm has deep interests behind the power that paradigm confers, and it's going to be a real struggle to veer the world into a different direction. We're probably going to have to lean on every possible advantage of this setting in terms of generating more economic value to be able to vault things from this highly controlled, centralized environment into a more decentralized, verifiable, well-governed environment. And in order to do that well, though, we're going to have to make sure that this is truly safer, not worse, right? So like the crypto industry does not have a good track record of proving that our stuff is better. Like, I mean, you have like all kinds of rugs that we shouldn't, yeah, it's kind of a mess, right? So we really have to demonstrate that this is truly verifiably a better governance environment and an economically better one. So like,
I was thinking of a question, like these things like collective intelligence, right? Like those are like tacit, tangible products that people who have no concern about like what is verifiable mean? Like this is a better experience.
yeah, concretely, yeah, exactly to that. Like concretely, a city of autonomous AI agents that are interacting with each other and generating value on their own, of like AI corporations, is economically more interesting than an LLM that can call and book a restaurant for me.
All right, yeah, first off, Juan, Ilya, thank you so much. This has been an amazing panel. This is like incredibly valuable knowledge. So I just want to follow up on the idea of where you think the most interesting next steps are for on-the-fly learning with AI agents, for instance. And I mean that in the sense of cool things are happening with like Inception and their new generative text model using diffusion, and how we might be able to use like LoRa's for actually like grabbing stuff on the fly and adding it. And even the older frameworks, like my mentor was Dr. Takuch, who did Disciples. So like there's tons of stuff. I'm just wondering where you guys think we'll start finding some really cool on-the-fly learning. I don't know, what direction should we look at?
I mean, I'm excited, effectively. I think the GRPO that DeepSeek published kind of shown a very simple framework for effectively reinforcement learning for these models, and applying that effectively to agents, even if you're, so like one of the main challenges with these agents is that it's a bunch of code and an LLM, right? And so when, like, because of this, your training process is so-called off policy, right? Because the code is not inside of the model. But I think GRPO is actually reasonably well generalizes to that. And so you can effectively train the model through even kind of code. And now, as you're getting sessions, as you're getting interactions, as this agent goes and does actions, you're effectively generating data on outcome, and you can use that to back prop through the system, as well as you can just sample a bunch. And so I think there's going to be both interesting direction of just agents that are continuously improving on whatever loss function. So like, let's say we have an autonomous agent whose goal is, I don't know, to amass the most money, right? Hopefully with restrictions to not make paper clips. And so like it can effectively learn from different actions it's taking and continuously improve its own model. But you can also have a different side of this, which is your personal, as you mentioned, low resolution matrix, which applies on top of the model that learns about you, right? Your phone number, your address, your preferences, what you like and what you don't like. And then every action that agents are taking now has that knowledge as well embedded. So I think like there's kind of few dimensions where we can now start doing this. There's still a little bit of research on like this, how exactly do like RL and F policy when you don't have like exact actions in this, but like it is a solvable problem, and so I'm excited about that.
In terms of, since it's kind of like the question is kind of fishing for different interesting lines of where to see some of the most interesting pieces, what I do for the latest AI things is X and Blue Sky are where a lot of the latest papers and most interesting, or like the what the fuck moments are coming in X and Blue Sky, and maybe after that they like hit TikTok and archive, and so like
In that order.
yeah, actually, concretely, with some rare exception of a very important planned launch that might hit archive first, but that's likely not the usual. And so I think, and especially like anything coming from not a huge lab hits Twitter and Blue Sky first. And so I would look at, I would just kind of like follow a set of accounts and just kind of scroll through what has high engagement. And these platforms are actually quite good at curating what is like very interesting right now. And so I would just plug that. Some of like there's like a good account called like AI safety memes or something like that. I forget what the exact framing is, but it's a good one that like reshares other results as like with like a meme of like how this is like very concerning for a bunch of reasons, and it's like a very good way of both surfacing like the important news and a bunch of the hot takes and like what this might imply.
Very cool. Thank you.
Amazing. Thank you very much to both of you. That's the end of our session. If you want to talk to these two later, you can contact their agents, their AI agents, and